Hi everyone, my name is Varsha and welcome to Study with Varsha. So yesterday I take one session and I discussed basic about the Google Cloud platform GCP, and I told that I'm going to start the GCP session. So before starting, I just want to tell you all, and it's not for GCP or for anyone, it's for everyone whoever wants to go into the DevOps field. This video is for them. This is what is DevOps lifecycle, what is DevOps, and why we need DevOps. Each and everything I will explain, and after that I will discuss one by one each and everything, so that you people will not have any confusion, because many of our students have commented that, ma'am, why we need DevOps only. So I thought, like, this video I have to make previously only, but I thought, okay, this is common, everyone knows. But yeah, that was maybe my fault. But you all have to be understand when you are going to start DevOps. So before that, we need to understand, yes, this is the basic requirement to start anything, that first we know what it is. So today first we will understand what is DevOps lifecycle. Lifecycle means what it will take. So the DevOps lifecycle is a continuous looping process that bridges the gap between software development and IT operations. So unlike the traditional models where we used operation were isolated, shared the steps, DevOps integrate them into a single infinite loops of collaboration, automation, and feedback. So, friends, in a simple word, if you will understand, so before DevOps, there was a developer and one operation team was there. So, developers used to write the code, and operations people used to deploy that. But there was a wall that if anything got failed, they said no. There is a operation people used to say no. There was an error in the code, but DevOps that developers say no. There is something from your side. So to avoid this conflict, the middle of the one thing, one person we used to keep, that is DevOps. So yeah, so there are multiple phases of DevOps lifecycle. First phase is plan. So one second. So what do you understand by plan? Plan means before a single line of code is written, the team must define the value they are creating. First thing is that goal. We should have to set the goal, like define requirements that will create, must define the value they are creating. Goals means roadmap, you can say, organized task. After that, some key activities is there, like backlog management, sprint planning, and even user story creations. So there are some tools like Jira is there, Trello is there, Azure boards are there. So with the help of that, we can plan the things. In the Jira, first we need, we use to create the tickets, we assign the title, description, what we are going to do, and in how much time it will take to complete. So all this thing will come to the plan phase. So this is the first phase of DevOps lifecycle. First we have to plan, like in real life also, if we are going to do anything, if you are going to see a movie, so first the plan is that you will go book my show something, you will go and on website, and then you will book your ticket, and then only you will take bath or get ready, and then you will take some bus or cab, and then you will go to the theater, and then you can watch. So for doing anything, there must be a plan is there. So that's what in DevOps life cycles also plan is there. So inside the Jira, we used to write, okay, we are going to do, for example, we are going to develop one application, so we will write what the things we are going to do. We are going to write in the description, and then who is going to do that, all thing we will use to write, and then we will give as a approver as our manager name or something. That is the first stage. After second phase, code should be there. So what in the code, here the developers will come into the picture. So developers write the code and commit it to a shared repository. For example, developer is using, for example, Bitbucket, okay, or somewhere. So they used to write the code in their local machine, and then they used to commit it to the shared repository. Like that repository is shared in the Bitbucket, or you can say in the GitHub. Okay, so now what the goal of writing all this thing? So it will write high quality, and it is version control code. What do you mean by version control? So that we can store each version of the code separately. For example, for the version 1, developer writes some code. If it will be pushed to the GitHub or anywhere, uh, so there, if it will lost from their local machine, then also it will be there. If he then again write the second version of the code, and if it got failed, so we can roll back to the previous version. So that's why it is important. Now key activities, what it will do, it will coding, code reviews, merging branches, so each and everything they used to do. And with what tools, what the tool required for it. So for it, tools is required: git, github, gitlab, and bitbucket. So see, in the plan we need to learn Jira, Trello, Azure board. So in any of this, it's not needed that you have to learn all this. Anyone you can learn. For example, I know Jira, okay, and I already make a video on Jira. So if you don't know, go and watch it. For the code, we can learn anything. For example, git, github, gitlab, and bitbucket. In my case, I know all these four, but it's not needed you it's not compulsory that you know all these four. You can just learn git and github. That is also more than enough. Now in the third phase, build means dev task, again developer. So once, like for example, they write the code, then they will commit it, and it is pulled and compiled into the executable form. Executable means artifact form. Now what it will do, it will detect compilation error early and package the application. So whenever, if you know any language, so before going to happen, it will compile. Okay, so if compilation error is there, it will detect all the things. Now compiling code, dependency management, creating container image. So for that we need one tool, that is maybe Maven, Gradle, Docker, Packer, anything it will be. Just a second, guys. Yeah, sorry for the inconvenient. So yes, so build tool means there are multiple build tools, like Maven is there, Gradle is there, Docker is there, Packer is there. So in most of the cases, if you will know like two also, like Maven or Docker, so that will be fine. But at least Maven I will suggest you to learn, because most of the interview cases they are asked Maven, and because it will support both Java and Python. So Maven is good, but if your company is using only Python, then Gradle will be good. But I will suggest you to learn Maven and Docker. So that is more than enough. And that only I am going to teach you. Maven I already covered, and Docker series soon I am going to start. Now test. 4 phases test. So the build is tested for bugs, security vulnerabilities, and performance issue will be there. So test means what? It is used to ensure quality and prevent bugs from reaching production. So if any bugs will be there, we can catch in test stage only, so that it will not reach to the production and it will not affect our application. So for that we use. Now uh, what it will do, unit testing, integration testing, static code, even performance testing, all these things we used to do in test. Now for that, what you should know, like Selenium, if you are a tester, okay, JUnit, SonarQube, and TestNG. See, we are a DevOps engineer. We no need to learn all these things. If you know, that's very good. But if you don't know, just learn one thing. I will suggest just go with SonarQube. So if you will have a good idea on SonarQube, our testing will be done. And all this thing, apart from that, tester will test it. But in our pipeline only, we will include SonarQube, so it will be good for us. Now once it will test, now the things will come in the picture, that is release. Here ops task was there, so the code has passed testing and is ready to be deployed. So this phase manage the version and approval. So it will schedule and manage the release to a specific environment, for example staging, prod. Now why we are using, because artifact versioning, change management, approval, so everything will happen. So now the what we can say, CI/CD come into the picture. So for that, if you will know Jenkins, that is more than enough, and I will suggest to go with Jenkins only as of now. Now after that deploy will come. So once the artifact will release, we have to deploy that artifact to somewhere, correct? So now the application is pushed to the production server. So what it will do, it will deliver the software to end user with zero downtime, because that is our key responsibility, that downtime will be zero. Now infrastructure provisioning come into the picture, like infrastructure as a code, configuration management, blue green deployment. Okay, because we want zero time deployment. So for infrastructure as a code, we need to learn Terraform. For configuration management, we can go with Ansible, and for blue green deployment, we can go with Kubernetes with Argo CD or AWS code deploy. So I will suggest to learn this three: Terraform, Ansible, Kubernetes, and Argo CD. That is more than enough. Yeah, that's it. Okay, now operate means ops. So this software is live. Okay, once it will release, we get the artifact, then we will deploy also. Now the operate, now we have to operate it because the software is live. So this involves day-to-day management of the infrastructure running the app. Like our application should be run always running up, and we should have to check like CPU utilization, memory, and everything, so that there will be no disturbance. So our goal is to ensure system uptime and reliability. That's what I was talking. Now the key activities like server patching, auto scaling, and database management. The tool is like Ceph, Puppet, PowerShell, Ansible. Okay, so for that, if we'll go with the Ceph and Puppet, that will be good, but I don't have that much idea. I will teach you Ansible only. Now monitor, for monitoring is very important, you know. So for that, data is collected from the live application to understand user behavior and system performance. So the feedback loops back into the plan phase. So the goals is detect issue immediately and gather insight for the future improvement. Key activity will be log analysis, performance tracking, and alert. So for that, Prometheus, Grafana, ELK stack, and that ELK stack means Elasticsearch, Logstash, and Kibana. So that we should have to know for monitoring. If you know Prometheus and Grafana, that is also more than enough. So that is some phases. Now there is 7 Cs for DevOps. What it will be and how it works, that also we should have to understand. 7 Cs of DevOps are core principles that make DevOps successful. So they guide how teams work together, build, test, deliver software faster and more reliably. So each of these Cs contributes to a workflow that enhances the quality, speed, and reliability of delivering software product. See, this if you don't understand, so in simple word or in a plain English, if I'll try to explain, there is something C, start with C like continuous. There is 7 things that you must have to know if you are a DevOps engineer. What do you mean by 7 Cs? First C means continuous development. Second is continuous integration, continuous testing, continuous deployment or delivery, continuous monitoring, continuous feedback, and continuous operation. That is only 7 Cs. In most of the cases, if interviewer will ask, if you are a fresher, that what is the 7 Cs of the DevOps? So that's what you have to answer. Now continuous development, okay, for continuous integration, continuous testing, continuous deployment, monitoring, feedback, and operation. That is only the DevOps lifecycle. If you want, you can take the screenshot as well. Now I will teach you what is in a very brief. Okay, what is continuous development, what do you mean by continuous integration, what do you mean by continuous testing, all this. So the first thing came into the picture, continuous development. Continuous development involve the iterative and incremental approach to the software creation, where development teams plan, code, and prepare software feature in a small and manageable units. This methodology enables rapid feedback, early detection of issues, and swift delivery of value and user. It integrates closely with version control system and automate tools to streamline the development process. For example, developer is there, it will commit the code and it will push to the source code management, GitHub, GitLab, or Bitbucket. After that, again, if developer 2 is pull or clone to their local system, okay, then developer 3 again it will push. So if you'll see this example, so imagine a team building a food delivery app. So instead of waiting to finish the whole app and testing it later, the team add features one by one. Like for example, on Monday they add a login feature and test it immediately. On Tuesday they add the search for restaurant feature and test that too. So each feature is checked and added to the live app as soon as it's ready. So this way, if there's are a problem in the login part, they can fix it right away without affecting other parts. That is nothing but continuous development. Means in whatever the stage any error will come, they will fix it immediately and they will test it. So we should not have to wait to complete the app. Okay. Now the second thing come into the picture, that is continuous integration. Continuous integration in a DevOps ensure that the code changes made by developers are automatically built, tested and integrated with the main code base. This process typically involves 4 stage feature: source code management, build process, code quality check and artifact repository. So if you'll see here, push the source code unit test cases. So developer push their code from local machine to a remote repository such as a GitHub. This allows team to collaborate, review and manage code versions easily. Okay. Now second, push the code, or we can say build the process. So what the source code is then compiled using a tool called Maven, which packages the application into an artifact, for example .jar, .var or .ear. Okay, after that third thing will come, that is build. Okay, so here Apache is there, it will build the code for executable SonarQube report. It will check the quality. So tools like SonarQube analyze the code for bugs, code smells and security issue. It generates the detailed HTML or PDF to maintain code quality standard. After that it will go to the upload artifact, that we can use Sonar type. Then it will go to the 6. So what it will be, send an alert or notification. So once the artifact repository, the generate build artifact are stored in a repository like Nexus, which serve as a central storage for future deployments. All these steps are automated using Jenkins, a popular CI tool that orchestrates the complete flow from fetching code to storing the final artifact. All these things we can do in where? Jenkins. If you want to take example, just take, let's say our team adds a new feature, tracking delivery person on a map, whatever Swiggy, Zomato you are using. So developers Mina writes code for the tracking feature and push it to the GitHub. Now as soon as the code is pushed, Jenkins pick it up and uses Maven to build the app and test it with JUnit. The code goes through SonarQube, which finds a few duplicate lines and suggests better practices. So once everything is okay, the final app version is served in Nexus as a jar. So this way, every small change is tested, verified and saved automatically without manual efforts. So that is nothing but continuous integration. Now, continuous testing. Continuous testing means testing the code automatically every time there is a change. So this helps catch bugs early before the app goes live. With DevOps and Agile methods, companies can use tools like Selenium, Lambda Test to test their application automatically. So these tools run tests faster and smarter than manual testing. Using a tool like Jenkins, we can set up the entire testing process to run automatically after every code change. So this saves and reduces human efforts. For example, let's say our company add a feature, apply coupon at checkpoint. Now, after the developer pushes these new features to GitHub, Jenkins automatically start the testing process. Tools like Selenium. So does the coupon code apply correctly? Does the final practice updated as expected, or does the checkout process still work? So if a problem is found, for example, the app crashes when a wrong coupon is entered, the test will fail and the developers will notify immediately to fix it. So this way, the team avoids pushing broken features to production and ensure the app remain reliable. For example, Selenium, this picture, Selenium test script, test ng, test report and Jenkins. Now, continuous deployment or continuous delivery. Continuous deployment is the process of automatically deploying an application into the production environment when it has complete testing and the building stage. So, we will automate everything from obtaining the application source code to deploying it. Okay. Now, first will be code done auto, unit test will be auto, integrate is as auto, acceptance test is auto, and deploy to production auto. So this is continuous deployment. While talking to continuous delivery is the process of deploying an application into the production server manually when it has completed testing and the build stages. Okay, so here we will automate the continuous integration process. However, manual involvement is still required for deploying it to the production environment, and that's what many MNC company used to follow. Code done, unit test, integrate, acceptance test. Now manual deploy to production. They used to follow. If in company like TCS, Infosys, they used to follow this process. Now, suppose this is an example. Suppose the team add a refer and earn features. The code is developed, tested, and marked as a ready to go live. However, the product team decide to launch it during a weekend campaign. So until then, the feature stays to standby in the staging area. So once approved, the code is manually deployed to the production using a single click. So continuous delivery ensure every update is deployable anytime, but the actual release can be controlled. So that's why we use, for example, push to the code GitHub, again pull the code to the Jenkins. Now this is the Jenkins part full, like Apache, Maven will be there for build, and Sonar will be there for execute Sonar report, upload artifact, and send to mail. This all will be controlled by Jenkins, and after that, this deployment process, Docker and Kubernetes, deploy image and deployment, this will be manual. Now, fifth thing come into the picture, that is continuous monitoring. So deploy lifecycle is incomplete if there was no continuous monitoring. Continuous monitoring can be achieved with the help of Prometheus and Grafana. We can continuously monitor and get notified before anything goes wrong. With the help of Prometheus, we can gather many performance measures, include CPU, memory utilization, network traffic, application response time, error rate, and others. Grafana make it possible to visually represent and keep track of data from time series such as CPU and memory utilization. So let's say your app suddenly takes longer to the load order history page. So Prometheus track the slow response time and send an alert to the team. Grafana show a graph that spikes during dinner hour when traffic is high. So the team uses this data to adjust the server setting or optimize the code. So this prevents crash and keeps the app smooth for all the users, especially during peak hours like dinner time. Now, continuous feedback. So once the application is released into the market, the end user will use the application and they will give us a feedback about the performance of the application and any glitches affecting the user app experience after getting multiple feedback from the end user. So the DevOps team will analyze the feedback given by the user, like that will be the end user, and they will reach out to the developers team, tries to rectify the mistakes that performed into the piece of the code. So if you are talking about continuous feedback, so it can increase the performance of the application and reduce the bugs in the code, making it smooth for the end user to the application. Now, for example, suppose users complain that the live delivery tracking is not updating fast enough. Now, the feedback is collected by via apps, reviews, customer, and so or feedback forms. The DevOps team analyze the issue and work with the developers to improve the tracking speed. Now, the next update include a fix the user experience improve. So, by responding to the feedback, the app becomes more reliable and enjoyable to use. Now, continuous operation. So we will sustain the higher application uptime by implementing continuous operation, which will assist us to cut down on the maintenance downtime that will negatively impact end user experience. So more of outputs, lower manufacturing cost, and better quality control are benefits of continuous operation. So let's say you need to update the Paytm system. So instead of settling the app down, continuous operation ensure the update happens in the background. So this this keeps customer happy and business running 24 into 7, especially during the peak times like lunch and dinner. Now, this is something which is the best practices of life cycle of DevOps. Faster or collaborative, implement continuous delivery and deployment, adopts infrastructure as code, embrace continuous development, integrate security that we call as a DevSecOps, utilize microservices, automate testing. So this is something which we have to understand, and this thing we will understand in tomorrow's class more deeply. See the future DevSecOps safety, plan, threat modeling, code. So what it is, test. So if you want, you can take the screenshot. So thank you for watching Study with Varsha. Have a great day, guys. And this is today what we discussed. Let's take a quick review that will understand what exactly the life cycle of DevOps and why we need DevOps. So all things we have understand today. So thank you for watching Study with Varsha. Have a great day and have fun.